In software engineering, we are discussing chapter number 30, product matrix. Function point analysis or function based metrics. Now you see here Mr. Allen, he developed this function point analysis in 1979 at IBM, and this was further modified by International Function Points Users Group. Now this FPA is employed to make estimate of the software project, including its testing in terms of functionality or the function size of the software product. So the cost, schedule and effort can be computed. As I said, this function point analysis may be used for the test estimation of the product also. So this function point analysis, this is going to give you a solution about the size of the solution. It can give you the cost, the schedule, the effort which is employed, which has to be employed. And the important part is it is independent of any kind of programming language. It is independent of any programming language. So it helps in estimation of testing projects also. And since you have all these numbers, now you can have a better idea to discuss it with your, say, stakeholders. Now there are different parts you see here, and you will be able to understand in a short while how does this function based metric or function point analysis work. These are the 5 measurement parameter which we also called as the information domain values. These all 5 things we need, the amount of them in your product. For example, this is just an example of all these 5 values, and these numbers are already empirically computed. For a low kind of product or the effort wise or other parameter wise, if it is low, you will use 3, 4, 3, 7, 5. If it is high, 6, 7, 6, 15, 10. Now I'll tell you how these numbers are computed. And then if you just want to do it for low or average or high, you just have to multiply these 2 rows. First, the counts you are going to give, and the row, any of these 3, low, average, high. So what are these first? Information domain values, measurement parameter. First is the application, and user is interacting with the application, and there can be some external data source. So the number of external inputs, these are each external input originates from the user or it is transmitted from another application. Inputs, they're often used to update the ILF, which are inside here, internal logical files. Now coming to EO, this is another parameter. Each external output is derived data that provides information to the user. So user will get the information. That is the direction you see. So what can it be? It can be a report, it can be a screen, it can be error messages. If you have 10 error messages, you'll only compute 1 or just number 1. Number of external inquiries, EQs. Now this number of external inquiry is the input which gives you a software response as an output, which is actually coming from the ILF. What is ILF? Number of internal logical files. So each internal logical file, this is a logical grouping of data that resides within the boundary, resides within the application boundary and is maintained via the external inputs. So these are internal logical files. What are external interface files or EIFs? Each external interface file is a logical grouping of data that resides external to the application, but provides data that may be of use to the application. So you have an application, input are coming from the user, there is external data source. So now we will assign a complexity value to each count. That is, you have certain value of these. For example, you have how many external inputs? I'm just giving you an idea. Okay, because we'll take an example and you'll see what numbers are we infer. Say external input EIs are 1, EOs are 2, EQs are 2, ILFs 1, EIFs 1. So now this is first column. Now you say I have to compute regarding my functionality point as simple or average or complex. So if you want to compute it as average, you don't have to worry about the first and third row. So 4 into 1, 2 into 5, 2 into 4. I am multiplying the first with the average row. Then 1 into 7 is 7. Now we are going to add them up, summing. So when we add this, 10 and 10 is 20, 8 and 7 is 15, 15 plus 20 is 35, 35 plus 4 is 34. 35, 39 I guess. Anyways, this number doesn't count. We'll take a proper example. So what we are going to do here is, if this number is 34 or 39, eventually it will be some number, and that we'll call as count total. This number 34 or 39, whichever number is there, the count total. And then we'll multiply it with 0.65 plus 0.01 into sigma fi. Now count total is computed. What is sigma fi? The sigma fi will be computed like this. Sigma fi will be, see, we have 14 parameters here, or 15 general system characteristics. So these are value adjustment factor VAF based on the responses to these questions. For example, data communication is required, reusability is required, online data is required. But what is the, say, complexity? That is, we'll give number from 0 to 5. 0, that means we don't require it. It has no influence. But 5, yes, it is very important. 0 means not important. 5 is absolutely essential. So any number between 0 and 5 can be assigned to all these 14. For example, data communication is very important. 5. Online update not required. 0. Reusability somewhat, so gave 1. So we gave all these 14 values some value between 0 and 5. And then all values you have to add. The number between 0 to 5 you have given, you have to add them. So when you add them, what do you get? This is sigma fi. Whichever number comes. As I said, 34, 39, or this is sigma fi. Whichever number it comes. And you just put it here, that will be the functional point. In the function-based metrics, this is an example. We want to use the function point metric, and this is a simple flow diagram for a user interaction function in, say, a safety, security, safe home system. So there is a hardware whether you are going to key in, and there will be a software inside it. So the function manages user interaction. What is the user interaction? For example, accepting a user password in order to activate or deactivate the system. This allows inquiries on the status of the security zones and the various security sensors, whether they are working, not, my parking is safe or not, whether my kitchen sensor is working, and then display of some prompting messages, also sending some appropriate control signal to various components of the security system. So these are the function managing the user interaction. But our idea is to compute the function point. So what are the three external inputs? We need to find out EIs. What are EIs? External inputs. So what are the inputs? Password is an input. The panic button is an input. External input. And the activate and deactivate is the external input. So how many are there? 3. So in front of external inputs, we are going to put under count 3. 3. Okay. How this 3 has come? Now we have 2 external inquiries. What are these? The zone inquiry, which area we are talking about, and which sensor we are talking about. So sensor inquiry. These are 2 external inquiries. So in place of EI, we are going to give the 2 number. Then ILF. How many ILFs are there? System configuration file. So we have 1 ILF. So let us give ILF as 1. 2 external outputs are there. So these are messages which are going outside and sensor status. So these are 2 external outputs being given. So we'll put external outputs as 2. Now what are EIFs? The external interface files. For example, your test sensor, zone setting, activate, deactivate, whether it is not done or not, what is the test status, and the alarm alert. These are external interface files. So we'll put 4 here. Now we have a count for each of these input parameters. Now we need count total. So let us assume that it is simple. We are putting the weighing factor for simple, and these numbers are empirically already found, and these are specific to certain application. So average, complex, these are already empirically predetermined value. So we are not taking average and complex right now. We are just saying that, okay, let us use it for a simple functionality. Okay, so we will not use the last two columns. Now we have to multiply the first two columns one by one. 3 into 3 is 9, 2 into 4 is 8, 2 into 3 is 6, 1 into 7 is 7, 4 into 5 is 20. Now we'll add them. Summation 50. 50 is our count total. This is our count total. Okay. We need to go for sigma fi. So let us say that it is 46 for a moderately complex product. But I need to tell you how this sigma fi has come. So these are all the general system characteristics. Now you have to give a value from 0 to 5 depending upon the importance of these system characteristics in your software or a product in terms of usability. For example, data communication you give 2, online data entry give 4, 5, reusability 0. So every number you have to give between 0 and 5 and just add them. And just assume that that number is 46. You can try with any other number, 40, 50, it will be below 70. Okay. So now this addition of these numbers, each number between 0 to 5 assigned to these 14 system characteristics, you add them, and I am just saying that it is 46 to make our computation easy. So this is 50. This is how much? This is 46 by adding all these. And then the final computation, 50 is the total count, 46 is the sigma fi, and the actual functional point is 56. 56. Now the thing is, why it is important? What do we infer from it? Our idea is not for computation. What do we do? So based on the projected this function point value, which is derived from the requirement model, now the project team can estimate the overall implemented size of the safe home user interaction function. Just assume that past history of this kind of project has given us that one function point translate into 60 line of code if we use the object-oriented language. So how many function points are here? 56. And one function point gives 60 lines of code. So 60 into 56, this will be the number of line of code. So this is the line of code estimation. For example, 12 function points are produced for each person month of effort. So effort is known, 12 FPs. What will be 56? How many person month? So just divide 56 by 12. This is, you will get the answer for the effort. So line of code you got, the effort you got. Now just assume that the past project, it was found that the average of 3 errors per function is found during the requirement and design review. So for each function, function point, there are 3. So you can assume there are 56 function point. There are 4 error per function point during unit and integration. So 4 you are getting, so 56 are here, 56 into 4. So you know about the number of errors per function point, and function point is known. So the line of code is known, effort is known, number of errors are known. So this kind of data help you assess the completeness of a review also the testing activities. Okay, how much code you have written, what effort you have to put, and the review and testing activities. That is why this function-based matrix is so important. Let us take one more example of a function point analysis. Now we have to compute the function point productivity, documentation, cost per function of this data. The data, the first 5 is basically the input parameters, the information domain, 24, 46, 8, 4, 2. This we are going to take as the input domain. Then the effort is given 36.9% month. Technical documents are 265 pages. User document 122 pages, and cost is $7,744 per month. Now various processing complexity factors are also given. Now you see these are the complexity factors already given. So there are 14 complexity factors between 0 and 5. This is already given to us. So number of external inputs, EI, is, because user input is external input. So what is the number? 24. What is the number of external outputs, which is the user output? So we are going to put 46 here. Number of external inquiries, which is the number of inquiries, we are going to put 8. Number of internal files, which is number of files, which is going to be 4. Number of external interfaces, EI, what it will be? This will be number of external interfaces 2. Now let us assume, for example, this is a made empirical values. I'm not going to use it. I'm just saying that for this particular product, this particular project, the numbers for say the average values are 4, 4, 6, 10, 5. I've just changed the numbers. This is for average. This box is just for example. I'm saying for this particular project, the numbers have changed. The 4, 4, 6, 10, 5. So what we'll do, 2 into 4, 96, 46 into 4, 184, 8 into 6, 48, 4 into 4, 40, 2 into 5 is 10. So these values have come. Now we are going to add them. And this is going to be count total, 378. And now we need to find sigma fi also. So count total is known. How do we know sigma fi? Because already the values are given. We don't have to give the number from 1 to 14. Otherwise we would have given 0 to 5 ordinals value to each of these 14 values, and then we would have just added them. So these are all values 4, 1, 5 like this given, already given in the question. So we'll just add them. So when we add them, we get 43. So don't go into the computation detail, just know how we do it. 43 is there. Count total is 378. Then we know the formula 0.65 plus 0.1 into sigma fi. Sigma fi is simply 43. Now 378 here, just put it, you get 408. Now this is the function points. Now you have to compute the productivity. What is the productivity? Productivity is simply the function point divided by the effort. Function point is 408. Effort is 36.9 person month. Divide them. What do you get? 11.1. So this is the 11.1 value is productivity. Then the documentation. For that we have to add the technical document as well as the user document. So you have 265 plus 122. Just add them. These are going to be the number of pages. And what is the documentation? The number of pages of the documentation divided by the function point. So what do you get? Just divide them. 387 by 408. This is going to be 0.94. So this is 0.94 for documentation. Now coming to the cost per function. And this is simply computed by cost divided by the productivity. So the cost total given is 7,744 per month and divided by the productivity 11.1, which we already computed. That already first thing we computed. So that will be $700. This is how we compute the function matrix. Matrix for specification quality. Now Davis and his colleagues, they propose characteristics that can be used to assess the quality of the requirement model, because the first thing is to gain the requirement. In terms of requirement model, we finally make the corresponding SRS, software requirement specification, or the requirement specification. Now we are interested in the matrix for this specification and what is the quality of this specification. For example, this SRS, what amount of all these or degree all these have? Specificity, lack of ambiguity, whether it is complete or not, correctness, understandability, verifiability, internal and external consistency of the document, the achievability, whether we can achieve these requirements or not, concision, the traceability, the modifiability. Traceability is that when you complete the project, can you trace back? Modifiability, can you change? Precision, how accurate, precise it is. Reusability. Okay. Along with this, the Mr. Davis and others, they also said that these high quality specifications are electronically stored. How? Whether they are able to execute, or if you are not able to execute because the specification requirement model may not be executable, they are at least interpretable only. And the annotation should be given wherever it is admissible. And the document or the SRS should be, or the model should be stable, versioned, organized, cross-referenced. These are very important. And specified at the right level of detail, this documentation or the product specification. So many of these characteristics, they seem to be very qualitative. From say accuracy we can compute, but what about the usability or the ambiguity? How do we check? So we will use the matrix. We assume that this is, for example, you have SRS, software requirement specification. The N sub R is the requirements in specification. So what is the NR? NR will be NF plus NNF. All these F and NF, these are subscript. So this first one is the functional requirement. The second one is the non-functional requirement. Non-functional requirement are specifically written, and non-functional requirement are some are explicit, some are implicit. Now this is a value, but in order to find out, says, a specific SRS function or value or metric, specificity, two people may understand the same requirement in different way. They may interpret the same requirement in different way. This may be possible. So how do we go about it? We have another metric, which is n by n. First is NUI, which is the number of requirement for which all reviewers, they have identical interpretation. That is, you and me both are interpreting the requirement in the same way. So NUI by NR, this is the number of requirement. All have same interpretation. And NR, you already know, NF plus NNF. So closer the value of this Q1, if it is 1, closer to 1, then the ambiguity in the specification is less. So this is how the metric can be computed. For example, you need to compute the completeness of functional requirement. There are functional requirement, non-functional requirement. So we have functional requirement and we need to know the completeness. For that we have this matrix, NU by NI into NS. NU is the number of unique function requirements. All the function requirement, no duplication, unique function requirement should be there. It should not match with others. NI is the number of inputs defined and implied by the specification. In the specification, a function or how many inputs it's going to take. So these are the inputs, NI. NS is how many states it will change. So number of states specified for this function. You can see it in the state diagram also. Okay, this is the completeness. So you get a matrix for completeness of functional requirement of the specification. Now Q2 will measure the percentage of necessary function that have been specified for a system. So this value will tell you, okay, these are the functions which need to be defined or they are specified in the function. These are the necessary function. But the one point about this metric is it does not address the non-functional requirement. In order to get that, in order to incorporate it into overall metric for completeness, functional and non-functional, then we need to validate the degree to which the requirements have been validated. For that, another matrix is there, Q3, NC by NC plus NV. Now NC is the number of requirements that have been validated. And we are saying that these are correct. That is why we have NC. They are validated and they are correct. This is NC. What about NV? These are the number of requirements that have not yet been validated. So this is the Q3, which is taking the overall completeness matrix. This is how we measure the specification quality. Architectural design matrix, this we are going to take in the next discussion. Thank you so much.